The most common use case for containerized applications is running stateless services, meaning services that don't store any persistent state. Stateless services are scalable and portable, which makes them prime candidates for Docker. Stateful services like databases can run in Docker as well, but they require other considerations. Persistent state cannot be stored within a container because containers can and will come and go, and so the data inside them is never permanent. One way we can preserve state for containerized applications is through the use of data volumes. The file system inside a Docker container is known as UnionFS, or Union File System. This file system is layered, which is why it's used for Docker containers and images. Data volumes are directories that do not use UnionFS and allow containers to write data that will persist past the life of the container. Volumes can also be mounted to directories on your host machine. One way to create volumes is to use the -v option when executing Docker run. When mounting a volume to your local host machine, you need to supply two absolute paths delimited by a colon. The first path should be an absolute path to mount the data to on your machine. The second should be the directory inside the container to mount. Let's try out an example using CouchDB, a simple document database that's purely HTTP. CouchDB defaults to port 5984, so we'll need to map it with the -p option. Next, we can mount the volume. Here, we've used the -v option to mount a volume to the directory named data in the current working directory on my host machine. The directory in the container that we're mounting is the CouchDB data directory. This means that anything written to user local varlib couchdb inside the container will be available in the data directory on my machine. We'll name this container couchdb and start it up. Now our couchdb instance is running. Since couchdb is an HTTP service, we can use curl to create our couchdb database named db. We can do this using a put request. Our database is now changed, so we can now take a peek in our data directory to see if anything was written. So all of CouchDB's state is now persistently stored on my machine, including a file for our freshly created database called db. This means that I could kill the CouchDB container and even remove it, but the state would be intact. Let's test this out by adding a document to our newly created database. We can simply post a JSON document to CouchDB using curl. Our simple document with the value Hello O'Reilly has been inserted into our database. I'm going to copy the generated document ID for use later in this example. Next, let's use a GET request with our new ID to verify the document has been persisted. And there's our message. Next, we'll kill our CouchDB container and start up a completely new one using the same volume. We have a completely separate container running CouchDB now named new CouchDB. Let's use the HTTP GET endpoint to retrieve our Hello O'Reilly document. And there we go. Our CouchDB state has remained intact despite shutting down the container that actually wrote the data. Volumes are a key aspect for running stateful services in containers. Docker offers another way to share data between containers, and that is through data volume containers, which we will discuss in the next lesson.